Two plates of steel can look identical, weigh the same, and cost wildly different amounts, because one of them gets its strength from heat treatment, not just chemistry. Part UHT is the rulebook for that second plate. Welcome back to ASME Section 8 Division 1 in 5 minutes. Season 2, Episode 6, Part UHT, Quenched and Tempered Steel Vessels. Part UHT covers ferritic steels whose tensile properties were enhanced by heat treatment, quenched and tempered, specifically, rather than steels that are simply strong because of their alloy content alone. That quench and temper process is exactly why these materials can run thinner walls at the same pressure than an equivalent UCS carbon steel. But that strength is fragile in a specific way. It comes from a precise thermal history, and almost everything that happens to the steel afterward has the power to undo it. Here's a sharp contrast with Season 1, Episode 3. Standard UCS carbon steel gets impact test exemptions from the UCS 66 curves, based on thickness and temperature. UHT materials don't get that option at all. Every single steel listed in Table UHT TWNETY3 requires Sharpie notch ductility testing, full stop, no curve, no exemption zone, no combination of thin and warm that lets you skip it. High strength from heat treatment comes with a testing obligation that never goes away. There's a subtler requirement too. Test specimens have to represent the material in its actual final heat-treated condition, not the raw plate is delivered. If the vessel gets hot formed or post-well heat-treated afterward, the test specimens go through that identical thermal cycle, including matching cooling rate. You are not testing the steel as it arrives. You are testing the steel as it will actually exist in service. And here's the sharpest rule in this whole part. Post-well heat treatment for UHT materials follows UCS 56 from Season 1, Episode 6, with one absolute modification. PWHT temperature can never exceed the material's original tempering temperature. Go over that line, and you're not just stress-relieving the weld, you're retempering the base metal past its designed point, softening exactly the strength this whole part exists to protect. It's such a tight constraint that the code allows tempering in PWHT to happen in the very same thermal cycle, on purpose, rather than risk running two separate heats that could conflict. Take SA517 Grade B, a common UHT plate steel. PWHT becomes mandatory above about 0.58 inches thickness, in a tight 1000 to 1100 degree Fahrenheit window, a real number pulled straight from the material's own table, not a general part UCS default. Miss that window in either direction, and you either haven't relieved the weld stress properly, or you've compromised the very strength you bought this steel for. Quick recap, Part UHT covers steel strengthened by quench and temper heat treatment, not alloy content alone. Every UHT material requires impact testing, no exemptions. Test specimens must match the material's true final condition. And PWHT can never exceed the original tempering temperature, or you undo the strength you engineered in. That's Season 2, Episode 6. Full material table is linked below on Weld Fab World. Subscribe. Episode 7 covers Part UCL and clad and lined vessel construction.